Okay, this is a follow-up on the previous video. The previous video was all about the electric field outside of a shell sphere. This is the same shell sphere of charge density. Charge is equal to area, Q over area. But it's all on this outer surface of the sphere. So we've drawn shape. And usually at this point I draw the electric field. And I'm going to skip this step for reasons. Okay. Instead, I'm going to skip ahead to drawing the Gaussian surface, because there's going to be a little extra information there. Drawing the Gaussian surface, where the Gaussian surface goes out to radius r, and the actual surface goes out to capital R, how much charge is actually inside that radius r? What is the Q enclosed out to a radius r? Well, none of it. Since this is a shell sphere, all of the charge is on the black lines. Okay? That's like saying how much candy shell is there in the chocolate part of an M&M? Well, none. That's where the chocolate is, not where the candy shell is. So the charge enclosed, 0. Therefore, the electric field times the area of the Gaussian surface will be equal to 0 divided by epsilon naught. The area is not 0, the area is 4 pi little r squared. Therefore, it must be the electric field inside is 0. There we go.